Alright, so let's look at our third question, which is do sum. This is probably the most popular question in all of LeetCode. You can go through the problem statement. I'll just explain. It basically means that we are given a vector and a target. We need to find two indices in this vector array whose values add up to this target. So in this example, we know that 2 and 7 add up to 9, which is our target. Then we return the indices of these elements, which is 0 and 1 respectively. It is also given to us that this problem will exactly have one solution. So let's start. So the very brute force solution which I can think of is that what we can do is we can pick one element from our vector. Let's say we pick 2, and then we are fixing one of the two numbers as 2, and then we will be looking for the other number, for which we will start looking from 7 onwards. So if we are fixing 2, then we will start looking for 7. In this case, the sum is equal to 9. But let's say instead of 7, there would have been some other number. Then we look at 11, and then we look on 15. And similarly, we will next fix this 7 and iterate through the rest of the vector. So what I basically mean is that we want two loops. One for fixing the number, and another to find the second number. So let's start with the coding. So let's first decide the length of our vector to be n, and now, as I said, we will have our outer loop from 0 to n, and my inner loop will be from 1 to n. So I just my inner loop will be from I plus 1 to n. So I want to look from the next possible number which can form a pair. This can be I minus 1. What are the constraints given to us? Okay, minimum length is given as 2. Alright, so now what is our task? We know that our num1 is this nums of I. This is fixed. Now I need to find this second num2. So for num2, for num1 and num2 to be a target, for num1 and num2 to sum to the target value, we need our num2 to be target minus nums1, right? So we need this sum. We need num1 and num2 sum to be equal to target. So we are fixing our num1. So all we need to do is we need to see if num1 and num2. So let me just write it simply so that it's easy to understand. So I know that my nums2 will be my nums of j. For my solution to exist, the sum of num1 and num2 should be equal to target. If that is the case, what do I return? I just return the indices, which is I and j. And it is always guaranteed that we will have one solution for sure. So we'll just return an empty vector here, just so that we don't get that error. Now, what do you think the time complexity of this solution is? the time complex, since we are doing two loops of n, roughly n, this goes from 0 to n minus 1, and this goes from I plus 1 to n. So this is roughly n, and this is roughly n. So in total we are doing our n square. So time complexity of this solution is n square. And as we can see that the length of my num's length is equal on the maximum can be 10 raised to 4. So if my time complexity is n square, then I know for sure that the maximum time can be 10 raised to power 8, since it is 10 raised to 4 multiplied by 10 raised to 4. So we will get 10 raised to 8. I am not sure if LeetCode will allow this solution to be passed, but let's first discuss the space complexity of this solution. We are not using anything, we are not using any extra space, so it's a constant space. Let's submit and check if it passes this problem or not. And yes, we are able to pass it because 10 raised to 8 is not that much of a time. So, but this was a very brute force solution. Now let's think about how we can optimize it. We want to optimize on the basis of time complexity. So we want something less than n square. Okay, tell me one thing. Now suppose that I have one value. I know my first value is 2. So I need a data structure wherein I can find a value 7. So let's look at this idea. Let's suppose that we have an empty data structure first of all. Okay, I'll just remove this answer, and let's say that we have a empty data structure firstly. Okay, I'm just representing it in this form so that you know what I'm trying to build upon. So first we encounter 2. Okay, from this example, first we encounter 2. So we need a value 9 minus 2, which is 7, to be in this data structure. Do we have it? No. As of now it is empty. Okay, no worries. If it's empty, I'll just push my current value to this data structure. Okay, so I push 2. Now I am at 7. So for 7 to be one of the two numbers, the other number should be 9 minus 7. So 9 minus 7 is 2. And does that exist in my data structures? Yes, it does. And there I have found my answer. Just to make your understanding stronger, let's look at another example. Let's look at this example, which is example 2. So the first number is 3. Currently, for this 3 to be in the solution, there should be another 3 present, because 6 minus 3 is equal to 3. But is it available for us? No. So we just insert our current value to this data structures. Then the next value is 2. So for this 2 to be the answer, 6 minus 2, which is 4, should be present in my data structures. Is it? No, it's not. So I'll just push this current 2. Now let's look at this third number, 4. For this 4 to be present as an answer, the value, there should be 6 minus 4, which is 2, present in this data structures. Is it present? Yes, 2 is present. So it means that I have found my two numbers. Now we don't care about the values, we care about their indices. So we need something such that we are able to store their indices as well. That's where our map comes in the picture. So by definition, map is a key value store. Let's say that we are searching based on our key. Okay, so let's write a map. So I have returned the key and value to be of int type. Now let's traverse this array. Okay, let's traverse this array I less than n and I plus plus. So I know my current value, so let me write my current value is basically nums of I, right? This will be my current value. Now I need the index of it. So I know that if my target minus, let's write it in a more modular way. Let's write my let's name a variable number. Let's just write second number. Okay, this should be equal to my target minus current value. Now I need this value to be present in my data structure. So I will look for it. How do you look a number in a map? You basically say mp dot find that number, which is second number in our case, is not equal to my mp dot end. So this means that this value, which is second number, exists in our map. So if it exists in my map, then I just need to print those indices. We have found it. How do you find a number? You find it based on your key. Okay, so let's complete the return section later. Let's say that this if condition was not full, then what did we do? We inserted our current value to the map. So the way to insert that current value will be my current value, and then I want the index of it, such that I know that this value is present at this index. Okay, so we have returned this. Now what are we returning? We know that the value of our map is basically my index. So if my second number and current value add up to target, if I found this second number in my data structures, I need to return the value of it. So the first index will be I, as we are in the current index. But the second index will be this mp of second number. Does that look correct to you? Alright, so and let's just enter a null vector because we need to have a return type. Now when we run it, our sample test cases are passing. So before submitting it, what is the time complexity and space complexity of the solution? We can see that there's just one loop going from 0 to n. So I know that my time complexity has reduced from n squared to n because it's just the one loop. And find operation in a map, in an unordered map, takes big O of 1 time on average, but it can take big O of n on worst case. If you're using just the map and not unordered map in C++, then it is ordered by default. So this find operation will take log of n time. So we can say if you're using an ordered map, our average time complexity will be big O of n because this is a constant operation. Alright, and for the space, we are using a map data structures. So we are at most entries in my map data structure can be n size. So now let's try submitting it. And there we go, 100%.